All right, guys, we are back and we're talking about algebra still, and now we're talking about solving algebraic equations. And I've taught algebra for years and years, and so we may be looking at this a little differently than perhaps you've heard in the past. And I'm making kind of a bold statement here that all of algebra, solving algebraic equations, all of algebra can be summed up in one rule. Now, we do make some assumptions there that we know some kind of sub-rules in terms of just the way our number system works and some of the basic principles of an equation in algebra, but pretty much everything gets summarized by that one rule. And so what is that rule? Well, that rule says that whatever is happening to the variable in the equation, whatever's already set up in the equation and is happening to the variable, you do the opposite. Okay? Now again, there are some assumptions built into this. One of the assumptions is that we know what the opposite means. The opposite is, what we mean by opposite is that if there is something being added to the variable, to the x or the y or whatever the variable may be, we would subtract that number. If there is something being multiplied by the variable, like 2x, then we would do the opposite. And the opposite of multiplication is division. If the variable is being squared, then we would do the opposite of that. We would take the square root. And so there's just some built-in understanding that you know what the opposite operation is of whatever's happening to that variable. Okay, and the assumption here also is that you understand the basic concept of an algebraic equation. If we have an algebraic equation, what makes it an equation as opposed to just an algebraic expression is the fact that it has an equal sign in it. That's why it's called an equation. And so that equal sign is the crux, is the balance of a balance beam. And so kind of the symbol of law with the woman standing there, or even the Statue of Liberty has a balance beam to where the principles of law are balanced. That's the concept of an equation here. And so if we do one of these things, let's say that there's a 3 being added to x, and so we're going to subtract 3 things. Well, if we subtract 3 things from this side, then we must subtract 3 things from this side, or else we'll throw the equation out of balance. Okay? We must keep the equation in balance at all times. And so when we say that we're going to do the opposite, that means whenever we introduce something new, now you need to understand that too, that when we say you do the opposite, so when you introduce something new that's not already there. So for example, if again there's a 3 being added and so you introduce a -3 or subtracting 3, if you introduce that as something new, you have to do it to both sides. Otherwise, you'll throw the balance of the equation off. Okay? And one more assumption here is that the equation, each side of the equation has been simplified as much as possible before we even begin this process. And so let's look at what I mean by that. So if we had an equation that looks something like this, or whatever it may be. It could be much more complicated than this. We can't start moving things around and so on because this side is not simplified and that side's not simplified. Okay? And so what we mean by that is that there can't be any parentheses, there can't be any exponents, there can't be anything like that that need to be simplified based on our rules from before of order of operations and so on. And so we would have to distribute through here. And so we would get 4x minus 12, multiplying 4 times x, 4 times a -3. And this side would equal 2 times x and 2 times a +1. Now we can start applying the rules of whatever's happening to the variable, you do the opposite. Okay? Now again, just a couple more quick assumptions here that you understand about algebraic equations is that if it is a linear equation, and what we mean by that is that the x, the variable, only has a power of 1 on it, or in other words, it's not squared or cubed or whatever. So if it's a linear equation, the goal is to get the variable all by itself. All right, so we want to get the variable all by itself on one side, and so when we do that, that's kind of the process of this, whatever's happening to the variable, you do the opposite. Okay, our goal is to get the variable all by itself on one side. Okay, if it were what's called a quadratic equation, that means that the x term, the variable, has a square on it. Okay, it is being raised to the second power, and within that, now we want to get everything on one side. In other words, we want to set the equation equal to 0. So it's a little different process in solving a quadratic equation. Okay? And so this rule here, whatever's happening to the variable, you do the opposite, make some assumptions within that, and we want to get the variable on one side by itself and all the numbers on the other side, and when we end with that variable by itself, then we'll have solved the equation. Okay? Maybe one more sub-rule here is that we essentially do the order of operations in the reverse order when we're solving an equation. So that PEMDAS thing that we talked about earlier, we're going to do those in reverse order. So as we simplify an equation or solve an equation, we're actually going to take care of addition and subtraction first. So we're going to get rid of things that are added or subtracted first. Then we're going to take care of multiplication and division. Okay, that'll be second. Then we'll get rid of exponents. And again, parentheses typically in an equation get taken care of like that example that we just did. Typically we take care of parentheses originally in order to simplify it. But if we have an exponent on a variable, then we usually take care of that at the very last. That's usually the last step that we do. And so we go through the PEMDAS order of operations in reverse order as we're solving an equation. So again, we'll look at some examples of this. We'll look at some quiz questions for this and talk more deeply about the process of solving an algebraic equation. All right?